So as I said in the last video, we're going to continue on looking at solving different situations using algebra. In this case, the last time we looked at equal values method, and that's when you had y equals something and y equals something. So we had the variable isolated on one side. In this case, I have y-intercept form and standard form. So the problem with that, I don't have the same thing equaling to each other. So I'm going to use a different method here. What I'm going to do is I'm going to use substitution. It's the same idea as equal values method, except the format is going to be a little bit different. So if y equals this chunk, and I have a y here, then that means I should be able to replace that. So I'm just going to take this, just like on a computer, I'm going to copy and paste it right over the y. So this is going to go right into there. So this gets rewritten as 2x minus 3 times, again, I'm going to copy and paste it in there. That's my old y value, right? And now, and then I just write equals -8. But here's the cool thing about it. If you look at this equation now, I've only have x's, and you've solved problems like this. So let's go ahead, and if you want to push pause and solve it yourself, that's ideal. But if you want to follow along, that's fine too. So now the first thing I'm going to do is I notice I need to distribute this. So I'm going to distribute -3 to both terms. So we have 2x minus 3x minus 3 equals -8. I'm going to combine like terms. So I got -1x minus 3 equals -8. Whole lot of negatives, but that's okay. I'm going to get, I want to get x all by itself. I already have x's on one side, which is nice. So now I want to get all my numbers on the other. -1x equals -5. So there's two ways I could do this. I could think about it as I could divide both sides by -1, x equals 5, or I can just say, hey, I'm going to take the opposite of this and the opposite of that and get my final answer. Depends on how your teacher talked about it, or how you think about it, actually. So x equals 5. Again, I'm not done, because when I solve a system of equations, I want to find out my value for x as well as y. But here's the beauty of it. This is just going to get substituted. I have a choice which one I want to substitute it in for. I'm going to substitute it in for the one that's already solved for y. So I've got y equals 5 plus 1, so y equals 6. Again, don't forget, if this is a situation, you want to add on the units of measurement for both of these. All right, now I'm going to just double check to make sure it really does work in both of them, because I might have made a little arithmetic mistake. So I'm going to take x, plug it into there. So I'm just going to put this down here. 2 times 5 minus 3 times 6. Does that really equal -8? It should, if I didn't make any mistakes. So I've got 10 minus 18, which is -8. So -8 equals -8, check. Again, I put a question mark because I'm checking to see if when I plug in x and y, does it really work? Or when I substitute in x and y, does it really work? Right? So now we have two methods. We have equal value methods and substitution method.